All right, welcome back to the next episode of Section 4. This one's going to be, we're actually going to be filling in the muscle of our spider program. In the last episode, we planned it out. We wrote actually a fair bit of the code, and we created basically the structure of the brain that we're going to be working with. In this episode, we're going to be going past the structure, and we're actually going to be developing out the muscle, the stuff that's going to be moving and scraping and grabbing the data for our spider. So if you didn't watch the last episode, it's going to be pretty helpful. We're basically starting with a fair bit of code, as you can see here. Like you don't really want to skip that part, and make sure that you understand it all. Don't just kind of like breeze over it and copy and paste that code, because it is important that you understand the structure of this in order to understand spiders. Because I would say spiders are like 80% structure and brains and 20% actual like scraping stuff. Like the scraping stuff is easy, as you'll kind of see as we go throughout this video. So let's start with our imports. That's probably the easiest part. We're going to need requests, obviously, so that we can actually pull data down, and psychopg. Can't wait to find out how I'm mispronouncing that. We're going to import it as PSQL just to make it shorter. Then beautiful soup. And if any of this stuff looks confusing, go back and watch the section 3. That's where I go over scrapers, and we'll go over those libraries and things like that, how to use them essentially in that section. So we'll also need JSON, sys, and time. Though I don't know if we're actually going to use JSON, but we might. I'll see. Okay, we've already imported sys up here. I'll get rid of that. So we've got our database information. That looks good. Let's start filling out the functions. We're going to start with... Let's start with the caching functions, because I also need to go back and fill out where we're going to be caching that information. It's fairly easy to like do these functions, but we are going to make sure that we're doing them correctly and that we're actually caching the data in the correct place. And whenever I say caching, just know that's me saying we're going to store it in a database. And I'm calling it caching for a very important reason that you'll discover in the next 2 videos. So for the actor, we've got their movies, a list of their movies. So movie list is equal to actor, and I think the key was just movies. It's actor. Let's change this actor object to just actor. Make it a little bit shorter. Actor link. That one is actor link. I've got my notes open on another screen, so I'm kind of referencing those. And then actor name. Actor. Now, I noticed in testing that there were a couple of times where the scraper was doing something weird, or the scraping portion of this was doing something weird, and it was adding in some like quotes and spaces and things like that within the actor's name. So we're going to go in here and just strip out, I think it was just double quotes. So we're going to strip that out. All strip does is it takes those characters out of a string. So the query. First, like we did before, we're going to make sure that the table actually exists. And that's also going to give us an opportunity to create our data format. So let's create our initial query here. And that is going to be create table does not exist. And this table is going to be actor data. And I'll explain this query in full after I get done writing it, just so it's a little bit clearer. We're going to do actor name, text not null, actor link, text not null, primary key. That's fairly important and also new. Movie list, text array, not null. All right, so a couple of additions here. Obviously, the text array is a little bit self-explanatory. It's pretty much the same as this, but for Postgres. So all it is it's a list of strings, essentially. And that's what our movie list is going to be. We could store this as an array of JSON blobs, I believe, in Postgres. We're not going to do that just because I want to keep it relatively simple, and parsing from a string into a dictionary in Python is fairly easy, so we're not going to worry about that. The primary keyword right here is new and also fairly important. That's basically saying that every single row in this table needs to have a unique actor link. That's going to keep us from adding actors that we already had in the database. It shouldn't happen since we're already testing to make sure that we're not retesting actors, but it is good practice to have primary keys in your databases because that kind of keeps you from creating those duplicates. And then we have the actor's name, which is fairly simple. Okay, so we've got our initial query. Now we need to execute it. But first we need to actually, I guess, so in this function we're going to build up and tear down our database connections within the function. So that may cause some issues later. If we're doing it all within the function, we don't need to do it within the main loop or within the main function. And I believe we are. No, I guess we're not. Okay, so it doesn't really matter. Let's go ahead and move on forward. So connection, psql.connect, and we need our database, our user, our password, our host, and our port. This one's easy, 5432. You could probably just leave that as default. This one is going to be, I think it's just called host. Yep, host, which kind of breaks our naming convention. DB pass. This one is DB user. And this one is just database. What did I call it? We're just gonna throw it in. Here's a literal test DB, if I can type. There we go. And then we'll instantiate our cursor. And if any of this doesn't make sense, then go back to section 3 where we went over the database stuff. Yeah, it was section 3, yeah. So let's execute that. And that is initial query. And we also need to commit it. Since this is a write, creating a table is a write to a database, you want to go ahead and commit it anytime that you actually execute a write query. All right, so one of the good things about having this right here is it's going to tell you your general format for your data. So we're going to create our add query, and that is going to be the query that we use to, you guessed it, add a row to the database. And we're going to start with insert into actor data, and our columns, actor name, actor link, movie list, and then our values. All right, and that should be it. We'll end it with a semicolon. I don't know if that matters, but it might. So we're actually, I looked here and it looks like we had some issues earlier whenever I was testing this, where it didn't really like the format that we had our movie list in, and I went through and cleaned it up like this. And I'll explain what I mean by cleaning it. I'm gonna create a cleaned array. Basically what we're going to do is we're going to create an array that just has, it's not an object, it's not a dictionary, it's just going to be a tuple. And what a tuple is it's just a pair or a trio or what have you of data. It's kind of, I don't know, it's an odd way to do it. Since in a dictionary we have a key to value relationship. A tuple doesn't have an implied relationship. It's just two things together. So we've got key, value. That's all a tuple is. And a tuple, I believe, can be any size, but typically they're seen as like size 2 tuples. So we're going to do, or at least in my experience, clean.append, and we are appending a tuple with the movie name. And I believe this was just the format that Postgres liked the most and was going to be the easiest to deal with later on. So the unfortunate part about doing stuff like this, this kind of series in general, I guess, is that you obviously have to test it out. I have to write my code before I jump into it. Otherwise, this is going to be like several hours of me just like debugging. Nobody wants to watch that. So I plan this stuff out, and what ends up happening is I find things that work and don't work, and I don't necessarily make note of why they didn't work or why I did them a certain way, which is more or less my fault. But you know, I could probably do better about trying to figure out exactly why those things are like they have to be done the way that they're done. But that is neither here nor there, I guess. We will continue on. So we're going to create a try, execute, or accept block. Accept. Exception as E. Alright, so what we're going to be doing here is trying to execute the query. And I'll tell you why we keep it in a try accept block here in a second. So we're going to execute the query. That is add query. And here's our data. We've got our actor name, our actor link, and a list version of our cleaned array. So fairly straightforward. We're basically explicitly saying that this is going to be a list. I don't know if that's necessary, but I did it explicitly, I believe, just to make sure that we've got the correct type of data going in. And then we'll just do a diagnostic or a debug statement committing the actor, and that is actor underscore name. And we'll go ahead and con.commit. I'm putting that in the wrong place. I was like, that doesn't look right. So I probably don't need to commit here. I could probably commit down here where we're about to close out the connection, but it doesn't really matter, I guess. So if we have an exception, let's print it out. And the thing is chances are we know what the exception is going to be. So we don't really need to print it out. My guess is that 99% of the time that we reach this exception, it's going to be a duplicate key error in database. So what that means is that it tried to add a new actor to the database where the primary key was already there. And that's why the primary key is really useful, but it does throw errors by default. So you do have to handle that error and make sure that that error is being handled correctly in order to continue. So if it's already in the database, we're going to hit this exception. We'll print out the exception just to make sure that that is the error that we're getting. And then we're going to print out basically our guess saying that it's because the actor is already in the database. So finally, we are going to close the connection. Very important anytime you open a connection here, you close it, because otherwise you end up with hanging connections and you don't want that. So the cool part about this is we can go ahead and essentially copy this over. Ooh, not all that. Here, I'll just do it line by line. So we're going to copy this over and just throw it into cache movie and make a couple of changes and we'll be good. We don't need to rewrite the whole thing because we do understand what this does. So let's go back up here. We're going to get, I think it's movie name is equal to, I think it's just movie, let's see, movie name. And I can't remember what the data format for the movie objects look like. So I'm gonna take that out. We're going to be pushing into movie underscore data. Need to look up the actual data structure of that database, or what it's going to look like. This stuff down here we're going to need to change, obviously. We can change this to movie underscore name. Change this right here. And let's go look at the data structure for our movie object. I would normally set this stuff up and put it at the top, basically. So it's movie name. So we've got a movie name. We should have a movie link as well. Let's see. Might be wrong. Looks like we don't have our data structure figured out for the movie object. At least not explicitly where I can see it. That's something that we definitely should have written down. Get actor movies. Okay, there it is. Movie name and movie link. So we only have to worry about 2 pieces of data here. Fairly easy. So that's something to definitely keep in mind. You want to explicitly write out your data structures. Otherwise, it's going to kind of be a pain to keep going through your code like I just did. So our movie object will have our movie name, our movie, if I can type, geez, movie link, movie link. All right, so we've got our name, our link. Let's see what else we'll have. And we'll have an actor list within that movie. So that's fairly straightforward. Actor underscore list. This is going to be our movie link. And this is going to be our movie name. So we're going to have 3 pieces of data. 2 of them we're putting up here. Then down here, same connection. That's going to stay the same. We're going to make this movie name, movie link, and actor list. So we're basically inverting all of this. Instead of an actor to movie list, we have a movie to actor list. Fairly straightforward. So we've got our add query there. Let's do the same thing with cleaning it all up, because I believe I did run into issues with the actor list earlier. So we're going to be iterating over the actor list, which I guess we need to grab somewhere, right? So we'll just go ahead and scrape it every time. Actor underscore list is equal to get actor list with the movie object. So that'll give us our actor list, fairly straightforward. For actor and actor list, looking back at my notes here, these are going to be, so this is a dictionary, so it's going to be a little bit more difficult to go through. So that's going to be, it's a list of names and links, and actor list dot items. If you want to know how to go through items in a dictionary, that's pretty much it. So you have to clean it up by name equals name dot strip. There were some weird characters in this one, and I don't know exactly why we ended up with parentheses in one name, and there was the double quotes as well. So then we're going to append the name, so just the clean's name. And that's kind of ugly. Let's do CNAME for clean's name. And then our link, which we shouldn't have to clean up at all. And that's just going to be link. All right, so we're cleaning up our variables here, and that's fairly vital whenever you're saving stuff to databases, because your scraper should be pulling stuff down in a fairly clean format, but it's not always going to do that. So you need to do some due diligence to make sure that those names are clean. Make sure you go through a good testing phase to make sure that as you're adding stuff to the database, it's adding clean data. Otherwise, you're really just gonna hate your life there. So I've got a note here that there were some weird exceptions within this main block, and I just ended up throwing it all into a try except block. Nested try except blocks are going to end up being your best friend if you don't use them frequently now. Exception as big E, since we've got small e in there. Print. We're going to print out error, weird exception, and functionally we should never hit this. I don't know exactly why I was hitting this earlier, but I did a couple of times apparently. And we'll print out the actor list because I believe that's what was giving me issues. There's some weird exceptions there. It's also kind of just a good thing to be tracking. This is actor list. All right, so we've got all of that wrapped up in a try except block. We're going to run the add query with the movie name, the movie link, and our cleaned list. So that should be fine. Can't see any reason why that would go wrong. Committing the movie underscore name. Get rid of that. We're going to commit it there, and we should be golden here. And we're also closing out our connection here, which is vital. Don't need a double return. That's weird. So we've got our cache functions done. Those are fairly simple, no real scraping involved there. Now, I'm going to copy and paste some code here in a second, and there's a reason why. It's because we've already done some of this stuff. So if we go up and we look at getActorLink, for example, that's literally just the function that we wrote earlier to get the actor's link from the search page. So that's why building these scrapers out, like the simple scrapers before moving on to spiders, that's why it's super valuable to do that. You can, start simple, start small, and then, iterate up and copy and paste tons of code. So if you don't know the code that I'm copy and pasting, I will walk through it, just kind of for the sake of making sure that everybody's on the same page there. But I'm not going to walk through it just very in depth because it is what we went through in section 3, last section, yeah. So I'm going to copy and paste this here. Make sure that I'm copy and pasting from the right function. Okay, so we've got our actor coming in. That is our actor's name that we're going to grab off of the command line. Our search request is our request with that actor's name to the search page on IMDB that we are going to then use to grab the link. The link we are going to grab right here from a list of names within a table. So if you go back and look at that episode, once we hit that search page, there's going to be a table full of actors with actor links and stuff like that, and we're essentially just going to grab the first one right here. So we pull that out, and if we don't find the actor, then we return actor not found with an empty string there. So fairly straightforward there, not just a ton of complexity. It's stuff that we already wrote, and we're actually, I think we've got another function that we already wrote as well. So to get a list of movies from an actor's page, we've already written the function for that too. So that is going to be our getActorMovies function. So let me copy and paste that. We'll walk through that the exact same way. Not super in depth because we've already covered it, and I don't want to be, I don't want to repeat myself too often. So we'll do that there. And basically what we're doing is we're going to the actor's page here, and we're grabbing the actual page itself, we're parsing it, and we're looking for this table with their filmography. And if we don't find the table, obviously we're going to return an empty list, and we're going to start going through the rows here. And these rows, we're grabbing out the movie link, and we're grabbing out the movie name, which is right here. And then we're appending that to the list. We're appending that object to the list, and we're returning the list itself. Again, super straightforward and code that we've already written. Copy and paste is going to be your best friend with this kind of stuff. Every programmer loves it when he can copy and paste, or she can copy and paste, especially if it's like Stack Overflow or something, where people kind of like write all of that stuff out for us. So the stuff that we haven't done is the get actor list when we're going from a movie to a list of actors, and we'll develop that out fairly quickly, just because it is fairly basic. It's very very similar to what we wrote to grab movies from an actor. So we're going to start with an actor list, and that is for some reason going to be it's going to be a dictionary, and we've got our movie link from our movie object. J, and that is going to just be a link. So our movie link is obviously going to be the movie page that we're going to scrape. And we'll go ahead and grab the name. Movie name is equal to movie obj at name. It kind of seems like it defeats the purpose of having an object passing, but it just kind of makes it a little bit cleaner up here where you're passing the variables. So first we're going to try to get the page for the movie. That's fairly basic. Movie page is equal to request dot get movie link. Nothing super complex there, except we're going to say this is possibly a network error. Couldn't get the movie page. All right, and we're just going to return an empty list in that case. But assuming that that does work, we're just going to preemptively throw all of this into a try except loop just to make sure that it does in fact run as a function. Try except is ugly and it may not be the best programming practice ever, but I essentially wrap everything in try except blocks just because I want the function to exit gracefully. If there's an error, I want it to error out gracefully so that the program can continue running, especially for spiders that you might be running for like 24, 48 hours at a time. You definitely want those to fail gracefully so that they keep running even if they encounter like a one-time weird error. So definitely those are going to be your best friend. Now we're going to create a beautiful soup object. Movie BS is equal to BS, and we're going to pass in the movie page.text, and we're going to use the HTML parser. So that is our beautiful soup. Okay, so now we have to get into the actual development. Let me create a new window. Right, and I will drag that over here, and we are going to go to imdb.com. Let's go to the expendables just because we've been using that movie a ton. So once we go to, well, we'll use number 4, I guess. No, that's actually in production, so let's not do that. The expendables, just do 3, because that one's already out. So we get to the expendables 3. And luckily we've already grabbed this complex movie link, so we don't really have to worry about going through the search page or anything like that. And what we're looking for is the list of actors. Now I grabbed from Topcast. Reasoning there is you can go down and get the full the full list of actors, but I believe you've got to make an extra request maybe. Fairly certain that in order to get the full list of actors, you've got to make like an extra request. And I just didn't feel like doing that. Plus, all of these actors right here. Yeah, I think you go right here to get to the full list. Yeah, so that's the full cast list. So you've got to make an extra request. But all of these actors are going to be the best connected actors in the movie. These are like the most famous actors in the movie. So it's kind of okay to just stick with them. They're going to solve our problem, well enough. It may not be the best way because you're not building as much breadth, but it'll do. So since we're grabbing that, we're going to call that feature cast. So let's go back to our code. Feature cast is equal to movie bs.find. and this is going to be where we actually find that list. Now let's right click here and inspect it, just like we had just like we had before. Jeez, can't talk. So I'm gonna maximize this a little bit, maybe zoom in a tad. We are looking for this section. So that section, it is an actual section tag, and it is title cast. That is the data test ID. So like I said in previous sections, IDs are our best friends because they are usually unique. So we're going to search for that on the attributes, data test ID, believe, yes. Then title dash cast, title dash cast. So we've grabbed the section there. That is obviously the larger, section that we're looking for, but not necessarily. Like, we're not going to be able to grab each actor individually from this. That's just the section that we're going to be kind of searching through. I didn't know Mel Gibson was in that. Huh. Okay, so that's the section that we're going to be looking under. We want to grab all of the cast members. So let's see kind of what these cast member sections look like. If we look back at the code and we use the highlights here on the left, we can see what section we're actually looking at. We want to grab probably this full div right here. Yeah, and that's got a test ID of title cast item. So that's going to be one individual cast member. So let's grab the div. So cast divs is equal to feature cast. So it's going to be a child of the feature cast object that find all. Since we're going to be grabbing several of them, it's going to be a div where the attributes are, I believe it's also data test ID, and it is going to be title dash cast dash item. Title dash cast dash item. And we can kind of see within the data dash test ID attributes that there's a parent-child relationship here. We've got a title dash cast, like all together table, and then we've got the individual items here. So we've got the items. We're basically going to want to loop through these items. So for cast div and cast divs, so we're going to loop through each of these, and we're going to pull out the actor name, the link, and we're going to actually throw that into our actor list dictionary up here. So actor underscore name and actor underscore link. Then we're going to create an object, or no, we're just using dictionaries here. So actor list, its key is going to be the name of the actor is equal to actor link. So that's going to be how we actually lay out our data here. So this is just going to create a series of relationships between an actor name variable and their link. So now let's pull out the actor's name. Usually those are hrefs, and we can see that they are. We've got the link to the actor's page right here. We can kind of recognize that structure from the last section. So we're going to pull out A. So that is going to be cast div dot finds. It's going to be a child of that cast div, A. And we're going to pull out every A with data dash test ID, since that's treated as well thus far. Title dash cast dash item. I think that's 2 underscores there. Let's go ahead and just copy paste that because I'm going to screw that up. Attributes equals data test ID equal to that. I believe that's 2. Yeah, so that's 2 underscores there. Probably would have screwed that up. And we just want to grab the text from this. So we don't want the href itself. We don't want the entire tag. We just want the text. Oh, that's supposed to be the link. Well, no. Actually, that's right. So we can grab both pieces of information from the exact same object. So let's copy paste that here. So here we're just grabbing the text because that's the actual actor's name. Here we want to grab the href. It's probably the wrong way to do that. I could probably do .href, but I'm more used to this, I think. So that's going to be how we do it. So we're grabbing the actor's name, the actor's link, throwing it into that dictionary that we're going to return later. We're pretty much done here. If there are any issues, we're just going to print out let's do exception as E. Print, ooh, that's nasty. Print something went wrong on this movie. I've got a note here that if the movie is in production, it's going to throw a weird error. So it might be in production. And then we're going to print out. I like to throw a tab on these just to kind of like say that like, hey, this is underneath this line where we say that we got a weird error. So I'm also going to make this an error, and we're going to do link movie underscore link and exception. Oh, what happened there? Tab there. Exception. String E. So IMDB also, if you go to the actor page up here, I'm pretty sure you can do it on Jason Statham because I think he's got a couple of movies in production. If you go to his actor page, I'll close this out so you can see a little bit better. That'll help. You can see down here he's got announced movies, filming movies, post-production movies. So if you hit any of these movies, it's actually the page is going to be laid out in a different way. I think this one might actually still work. But there are some pages where it throws an error if it's still in production. So you want to make sure that you handle those errors. And it may not be the case that that's the error that we get to down here, but it also might be. And then we're going to return our actor list. So, looks like we're not using movie name for some reason. That's odd. Huh. I guess I extracted it for no reason then. We've got our get actor link function. We've got our get actor movies function. We've got our get actor list from a movie function. We've got our cache functions. And it's looking like it is time to move on to our main loop. We're kind of in the home stretch here though. We don't need to worry too much about any of the rest of this this implementation because it's going to be fairly easy. Let's go down and we're going to cache some stuff. Basically, we want to cache the actor object and the movie object when we're done going through those. So if we've already been through those, we've gone through all of the actors, all of the movies within, that actor's history, that's going to be when we actually want to cache those objects. So right here, where we're appending to the triad actors, we know that we're done. So cache actor, and it needs the actor object right there, and same thing for right here. Cache movie. I'm fairly certain we're going to run into an issue here, but we'll deal with that issue when it comes up. Okay, so let's go through our main loop here. This is going to be the meat and potatoes, and at the end of this, I know y'all are going to be shocked, we are actually going to, run it. I don't know, it's like a weird feeling. We've been writing all of this code, and we haven't run any of it yet. And let me pause real quick and say, that is not how you'll actually write out a spider or a scraper in, real life. You're not going to write all of this code and then run it. You're obviously going to test it line by line, and Lord knows that there's a very long iterative process to do all of this stuff. You're not just going to write it once, run it once. That's not how any programming ever works. So if you've been testing this stuff out over time, totally fine. That's what you're supposed to be doing anyways. So we're building our actor object already. No big deal there. Let's see. really, there's not going to be just a ton that we need to add to this list. I'm going to add a couple of like diagnostic messages, like for example here. So we're starting on a new line of, or a new level of depth. So print depth. And we're going to make this a fairly long, diagnostic message because it is relatively important whenever you start on a new line or a new level of depth that you print that out and kind of log basically where you're at because you can see where the errors are. So length of actor list. So that's going to be the large actor list that we're appending to every single time we go through a new actor or a new movie. So len actor list. And let's just print out how many movies we've tried already. Movies tried. Len tried underscore movies. And then same thing for actors tried. Tried underscore actors. So fairly long diagnostic here, but it's printing out important information. All right, so we're creating our copy right here. Let's actually cut this and put it after. Ooh, not there. There. So for every actor, if the actor is not in tried actors, going through my list just to make sure that all of this stuff is how we kind of want to do it. If movie is not in tried movies, so we're getting the actor list right here for current actor and actors. This might actually work without us really having to worry about much. See, that's what I was saying. Like if you do your planning early on, you really don't have that much else to do afterwards. Name equals name.strip. Just making sure that I'm doing all of this. It looks like we're just about good to go. So let's print, or let's run it. I know, very exciting. Let's run it and see what is missing. So run without debugging. We'll open up a terminal. No module named CycloPG2. Now it seems like we might be running. Yep, there we go. All right. So if current actor at actor name, string indices must be integers. That's interesting. Line 219. So now is when we're going to actually get to go through that debugging process that I was talking about earlier. Actors, so let's print out current actor and just see what it is. Print current actor. Should happen right before we get our error. Let's maximize this so we can actually see what we're doing. So the current actor is literally just the actor's name. That's interesting. And actors, we're creating actors up here for each movie. Huh. So it looks like we've got some kind of weird data error. We're not creating the data the way that we think that we're creating the data. Same thing there. Oh, so we're getting a list. So this is current actors and actors items. So that is okay. So so name and link and actors.items. So we're basically, we've got a dictionary here, and we can just make this name. If not, tried actors.append name. So let's do it that way. There we go. All right. Hold on, guys. I think we're actually doing this. Looks like we might be getting some errors up here. No, we're not. We're doing it right now. All right. So we've got our spider running. Let's check back over on our database and make sure that we are actually inputting data here. So I've already got this open. Let's see what we're connected to. We're in TestDB, so let's look at our tables. So we've got a movie data. Looks like we're not inputting actors yet. It's not a big deal. So let's do select from movie data. We're going to limit 5. That's just going to basically say we're only going to get 5 entries from this. Oh, that's weird. There we go. So this is ugly as all get out, but so it's giving us a list of actors here. And let's quit out of this. So select from movie data. We're just going to grab 1. So we've got our movie name, then our movie link, and then our actor list. And that actor list should be a list of objects. So we've got Jason Statham there, and then we've got his link right there. So it looks like we're doing that cleanly. And we should very soon be getting actors in. So let's do DT, make sure that we don't have it yet. Looks like we don't. So we should be caching actors fairly soon. I might just kind of wait for that to happen and then flash back over here and we'll view that. So I don't know why we're printing out this big object right here. That might be... Where are we printing that? It's probably right here, I'd imagine. So somehow we already reached max depth. So it looks like we've got an error there because we definitely shouldn't have hit our max depth already. Let's see. I don't know why we would have hit our max depth that early. We definitely shouldn't have. So we're setting our max depth up here. So it's equal to 5. That's a fairly large maximum depth. Let's minimize this so we can go through the code a little bit. Let's close out our actor link. All of these functions should be right because it's gathering the correct data. So let's go ahead and close all of this stuff out. Our error is going to be within our actor loop, or within our main loop, sorry. So we're iterating over depth once here, or we're incrementing depth once here, sorry. Let's make sure that we're not incrementing it any more than that. We shouldn't have found, so we didn't find KB here. It's saying Jason Statham already in database, so we should have created our actor data database then. Yeah, we did. So select from actor data limit 1. Oh, the output of this is so ugly. So Jason Statham, we've got his link there, and then we've got his movie list. So let's do select count from actor data. So we only have Jason Statham in there, so that's worrisome. Let's go back through here and kind of follow. So if depth is greater than, so we hit that error message. We reach max depth without finding KB. So we reach this error message. So for some reason, we are iterating over these loops. And I don't really know why. We're like very quickly iterating over these loops. So let's go back and look at our log. If we go back up here to the beginning. Ooh, I actually forgot to add sleeps in here, which is very bad of me. So at depth 1, length of actor list is 1. We haven't tried any actors. We haven't tried any movies. We're trying Jason Statham here. So we're just, So, that's not what I'm trying to do. I'm going to take a break and figure out exactly what's going on here. Alright, so I think I've found the problem and I've got it running successfully. You can actually see it down here. And one of the things that you'll notice fairly quickly if you're watching the output down here is that it's incredibly slow. It's honestly like going even slower than the test version that I created before, so I might debug it a little bit and try to make this version at least the best version that I can without doing the improvements that we're going to talk about in the next video. So I haven't changed any of the structure of anything. I've kind of like made sure that there aren't any functions that are taking particularly long. There are not. It's just the way we've got it designed is incredibly slow. There are probably a lot of improvements that you're thinking about right now that we can make. I know right off the bat it was actually difficult for me to write it in the way that I'm writing it right now because there are just some glaring issues that I know that I can fix fairly easily. We'll go through those glaring issues in the next video, talk about design decisions, and start thinking about possible improvements that we can make to our spider. So thank you so much for joining me on this wild ride. In the next video, it'll be mainly a whiteboarding session. We're going to talk about these improvements. We're going to talk about how we're going to make those improvements, and then in the video after that, we're actually going to make those changes. So like I said, thank you so much. Reviews for the course, super helpful, super welcome. And any kind of feedback that you have on things that you didn't quite understand, just let me know, and I will try to go over them with you either one-on-one or in a follow-up video. Thank you so much.